Hello, and welcome to Intermediate Algebra, Unit 4, Lesson 4, Solving Systems of Equations Applications. After finishing this lesson, we should be able to set up a system of equations as described in a two-variable value problem. In other words, in a word problem. You're not given the equations, you have to figure them out first. And then we will solve the system of equations using the methods we have just learned in lessons 2 and 3, substitution and elimination. So setting them up and solving them are the two objectives when we're given these types of word problems. So systems of equations are important because many models in engineering and science are systems of equations. If you take an engineering course, you take a whole course in linear systems. And then maybe in nonlinear systems. I had several of them in college. And then in order for a system to have a unique solution, it must have the same number of independent equations as it does variables. So if I have 3 variables, I need 3 equations. If I have 2 variables, I need 2 equations. We will only work with 2 variables here for the purpose of getting you to understand the concept rather than making the algebra complicated. But if you have 5 variables, you need 5 equations to find the value of each. We can use either substitution or elimination to solve these, whichever you prefer in whichever situation. You won't be told in a quiz or test you must use substitution to solve this one. We're looking to see if you set up the system of equations correctly, and then if you solved it using any valid method. So here's our first example. You have $1.50 and change with only nickels and dimes. If the total number of coins is 18, how many of each coin do you have? So it sounds like there's not enough information here first because there's only 2 numbers. But you have to take in some other understandings, like how much is a nickel worth and how much is a dime worth. If you ever have a question on that, you can always ask me. I will answer questions like that. So you have to identify the variables. Well, the $1.50 is not a variable, the 18 is not a variable, but I was asked, so you look at the question for that. How many of each coin? Well, what do they mean, each coin? Well, the 2 types are nickels and dimes. So we need to find the number of nickels and the number of dimes. So that's what we're looking for. Those are our variables we're trying to solve for. So we're going to let n represent the number of nickels and d represent the number of dimes. You could use x and y, but you would have to write. You want to make sure you write down, no matter what you use, n equals nickels, d equals dimes, or x equals nickels, y equals dimes if you prefer. In application problems, I like to use more meaningful variables. So here's the example stated again. I have 2 variables. I need to find 2 equations to write. In these types of coin problems, where you know how many coins you have and how much money it's worth, you will always have 2 equations from these 2 pieces of information. The first one is just how many coins are there. How many if it took all the nickels and dimes and counted them up, how many would I have? And the second equation comes from the value. So the value your nickels contribute is 0.05 times the number of nickels there are. That's how much value to the total all your nickels contribute. And the value of dime is 0.1, so 0.1 times the number of dimes tells you how much of that $1.50 comes from dimes. That's where your second equation is going to come from. So the number of coins is said to be 18, so n is nickels, d is dimes, n plus d is 18. Right there. Now, how much money n nickels is worth is 0.05 times n. You could set up this, and how much money number of dimes is worth, if you're working in cents, is 0.1 times the number of dimes, equals $1.50. The other thing you could do, you could either write it this way or you could work in cents. You could change that $1.50 to 150 cents, and you could write 5n plus 10d, 5 cents times the number of nickels plus 10 cents times the number of dimes equals the total number of cents I have. Some of you will find that simpler, but you have to make sure that you move everything 2 decimal places to the right on both sides of the equation, basically. or you just have to make sure you don't write 1.5 on the right. Sometimes students will write 5n plus 10d equals 1.5. No, if you're working in cents, then the value of your money is expressed in cents also. So I continued to work with the decimals here. So we have a system of equations to solve. Substitution works because it's almost always easy to isolate either the n or the d. So what I did was I took the first equation and I solved it for n. And then in the second equation, that's where n was. I changed that to 18 minus d. I multiply everything through. And you might be looking at the decimal saying that makes it look hard, but don't forget you do have a calculator. You need to know how to use it. Having a calculator is not a solution to all your math woes. So I multiplied everything through. 0.9, that comes from here. And there's my 0.1. I just dropped the 0 because it's not significant. So negative 0.05 plus 0.1 gives me a positive 0.05d. So if you're saying, well, how do I use my calculator to do this? It has d's in it. Just use the numbers. And then I move the 1.5 minus 0.9 gives me my minus 0.9. That's not divided by. Gives me my 0.6 over here. And then I divide both sides by 0.05 and I get 12 dimes. So if I have 12 dimes, I have to figure out how many nickels I have. And that goes back to, well, how many coins did I have? The number of coins I had added up to 18. So n plus 12 will be 18, so I must have 6 nickels. Now to check this, I see if 6 nickels and 12 dimes makes $1.50. So 12 times 0.1 plus 6 times 0.05. Well, and for coin problems, you can almost just pretend you're counting change. This gives me $1.20. This gives me 30 cents. If I had 6 nickels, I'd have 30 cents. So that is $1.50. So that is kind of a classic coin problem. Now, here's another type of problem. A problem with two types of items that are sold at different prices, like a children's ticket and an adult's ticket, things like that. So 500 tickets were sold for a Saturday evening performance of a play. The tickets cost $7.50 for adults and $4 for children. Okay, so there's your two different things going on. A total of $3,312.50 was received for all the tickets sold. How many adults attended the play? So we know how many tickets. That's the same as knowing how many coins. So, and here's the tricky part. It is not given to us in numeral form. You have to read and understand that 500 is this. They have given you a number there. So don't just hunt for numbers in these word problems. So 500 tickets. Well, there are only two types of tickets, adult and children. So the A is the number of adult tickets sold. C is the number of children's tickets sold. Just like N was the number of nickels, D was the number of dimes. So that has to equal 500. But then you know how much money you took in. Well, if you sold one adult ticket, it was $7.50. If you sold two, you would have taken in $15. If you sold three, you would have taken in $22.50. This is the amount of money taken in for adult tickets. The price per ticket times the number of tickets. And next to it here, this is how you figure out the amount of money, how much per ticket times the number of tickets. So you're letting C be the number of tickets. That's what you don't know. You know how much money you took in, but you don't know the number of tickets, so you represent it with a C for the children's tickets. So again, substitution works very well for this. You could use elimination if you wanted to multiply the top equation by -4 or something like that, or -7.5. But I did by substitution. I took the first equation and found A. We say that's A in terms of C. When you see this in terms of, what that means is you have an A equals, and there's some stuff with a C on the other side. So that's what in terms of means. So I replace the A in the first equation with 500 minus C, and then 7.5 times 500 is 3750. 7.5 times negative C is minus 7.5C, and so on. So I just Now I combine like terms, gives me the negative 3.5c. I subtract 3750 from both sides, and you say, well, it gives me a negative number. That's okay. You have a negative value over here too. So I divide both sides by negative 3.5 to get 125 children's tickets. I'm going to go back to the total number of tickets sold to find the number of adult tickets now. So I've replaced my children's tickets with what I just found. That was a C before. Now it's 125. And when I subtract 125 from both sides, I get A is 375. Now I check this with the value equation. I sold 375 adult tickets at $7.50 each, and I sold 4 children's tickets. Not a very popular show for children, huh? Oh, I'm sorry. So $4 each. It is a very popular show for children. There's 125 of them. $4 for each children's ticket, so there were 125 children. When I multiply that out, I do get 3312.5. So my answers are correct. There were 375 adult tickets sold and 125 children's tickets. I messed myself up because I revert. This should have been 7.5 times 375 if I wanted to keep. This is the number of tickets. This is the cost. That's why I was confused. But that's the value of each. Added together does come out to my total. So let's see our next example. This is the third type of problem we will work with. We'll just stick with these 3 types of problems. We may see some number problems too, but those are actually easier than the coin problems even. So both equations are from the value of 2 different situations. In this case, you know how many tickets were sold and what they added up to in 2 different situations, but you do not know the cost of each ticket. Now, in both situations, the cost of each type of ticket is the same, but you don't know what that is. So the school that Perry goes to is selling tickets to a fall musical. On the first day of ticket sales, the school sold 10 senior citizen tickets and 10 child tickets for a total of $90. The school took in $27 on the second day by selling 5 senior citizen tickets and 2 child tickets. Doesn't sound like, well, maybe they're leaving out the adult tickets, but it doesn't sound like a very popular musical. Anyway, find the price of a senior ticket and find the price of a child ticket. What's different here than the last problem is we're trying to find the number of each type of ticket sold. Now we're trying to find the price. So, finding the price, so I'm going to let S be the value of a senior ticket. Not the number of them sold, but the value. And let C be the value of a child ticket. In example 2, we knew the value and just didn't know how many. So the first day I sold 10 senior tickets, or Perry sold 10 senior tickets and 10 children's tickets, and that added up to $90. This was dollars on the other side there. So that added up to 90. The second day he told 5 senior and 2 children's, it added to 27. Now this one you might want to solve by elimination. So I multiplied, so the 2 equations come from the 2 different days in this case, and they look very similar. So I multiplied the day 2 by negative 2. That made that a negative 10. The 2 became a negative 4. And the 27 became a negative 54. Very important you remember to multiply the right side. So then I add the 2 equations. And when I add the 2 equations, these are going to go away. And I'm going to get 6c equals 36. Divide both sides by 6. And I get c is 6. So now I know the value. A children's ticket costs $6. Now I need to find how much a senior ticket costs. So substitute the value into one of the equations. I use the day 1 equation. So here is my 6 for the price of a children's ticket. So 10 times the price of a senior ticket plus 10 times the price of a children's ticket, which was 6, is 90. I subtract 60 from both sides. I get 10s is 30. So S is 3. A senior ticket was $3. So I can go back and check this using the original day 2 equation. 5 times 3 plus 2 times 6, 27. Yes, so that's correct. Now, I didn't carefully label these, but remember, the answers in this case are dollars, not number of tickets. In example 2, there were number of tickets. So, There's one of each type of problem for you to try here. I would like you to stop the video in a moment and try each of them and then come back and check your answers. If you do not get one of these or many or several of these, you need to get help right away and get it straightened out, or look for your mistake once you see the answers. If you can find your mistake yourself, that's fine. That means you just made a mistake. But if you really don't get close in any of them, you're going to need to get help very soon to understand this. If you're still struggling with how to solve by substitution and elimination, you need to straighten that out first. Okay, so stop the video. Try this. Okay, you're back, and here are the answers. Thank you for joining me in this edition of Math Teacher to Go, and I will see you next time.